Block A in figure 6.45 has a mass MA is equal to 4 kg and block B has mass of 2 kg. The coefficient of kinetic friction between block B and the horizontal plane is mu k is equal to 0.50. The inclined plane is frictionless and at angle theta is equal to 30 degrees. The pulley serves only to change direction of the cord connecting the block. The cord has negligible mass. Find A, the tension of the cord, and B, the magnitude of the acceleration of the block. Okay, and we need to draw all the forces that works on those two blocks, right? And here we have in the inclined part that is frictionless here. So this one is frictionless. And the horizontal part here has some coefficient of friction here, mu k, that will equal to 0.50. Good. And now let's draw all the forces that works on this block A here. Okay, obviously it has its weight, right? So let's name this here as the force of the weight of block A. Right, but this one is not in the x or y axis here. I will use this one as x axis and this one is y axis. Okay, and because this one is theta, theta is here, right? So we'll have theta here and we will have this one here as FWA cosine of theta, right? Why cosine? Because this is an adjacent side and this is hypotenuse for this right angle triangle, right? But then we can also project that into this part here, and that one here is FWA but sine of theta, because this was the opposite angle. Good. And we don't have any friction here because this one is frictionless. However, we have that force that works there, which is the tension of the rope, right? So we will have this one here as T, right? And we also have this force that push this MA by the surface, and that will be our normal force here, F and A. Okay, however, we only care about the x-axis because this is frictionless and the movement of the direction logically is there, right? So that will be our direction of movement. So I want to use that direction as positive 1. So here I can use the Newton's second law. Sigma F is equal to the mass times acceleration, and this one is on the x-axis. Okay, so we'll have FWA sine of theta, but then minus the tension, right? So have T, and that will equal to the mass times acceleration, and we work on block A, so that will be mass of block A times acceleration. But then this has to be MA times G, and then sine of theta minus T, and that will equal to the mass of A multiplied by the acceleration. Okay, now let's plug in the numerical values. Block A has mass of 4 kilograms, so I will have 4. G is 9.8. Sine of theta, so I have sine of 30 degrees. And then minus T, and that will equal to the mass of A, that will be 4 multiplied by A. Okay, now we can isolate this, all the variables on the left hand side. So T plus 4A, and that will equal to 4 multiplied by 9.8 multiplied by sine of 30 degrees. Or we can calculate the numerical values in calculator here. So we'll have 4 times 9.8 multiplied by sine of 30. 4 times 9.8 multiplied by sine of 30. Okay, and that will be 19.6. Okay, we'll have 19.6. And here nothing that we can do, right? So let's just save that as equation number 1. Good. And now let's draw the forces that works on block P here. Obviously, we have the weight of P pushing it down to the earth. So I will have FWB. But then this surface also pushing this P here by the contact force or the normal force to block P, Fn of P. And here we have the reaction force from this T here to the opposite direction, right? So we'll have T pushing, not pushing, pulling this there. So I'll have T, but then if the direction of movements is there, we have the friction moving to the opposite direction of the movement. So I will have force of the friction here, FFP. But remember that FFB here is equal to mu K multiplied by FNP. But then we need to find out what is FNB, right? And we need to use this vertical axis here to find that out. So we will have sigma F on the y-axis. That will equal to the mass times acceleration also on the y-axis. However, the movements here is following the x-axis and no movements on the y-axis. So on the right-hand side, we have this equals to 0. Right? And so we will have this one here. The positive one is FNB minus FWB. And that will equal to 0. And we can isolate for FNB. And that will equal to FWB. But that is mass of B times G. What is mass of B? 2 kilogram. What is G? 9.8. So we'll have our FNB here. That will be 2 times 9.8. That will be 2 times 9.8. 19.6, I think. Yeah, 19.6. And the unit here will be in Newton. Okay, so now let's do our analysis on the x direction. So we'll have sigma F, but this time on the x direction, and that will equal to the mass times acceleration. Okay, and I want the positive one to be the direction of movement, so this is going there. So we'll have T here, and then minus FFP, and the mass here, we are working on mass P, so the mass of P times our acceleration. Good. Now, so we'll have T minus FFP. What is FFP? Mu K times FNB. Good. And that will equal to MB times A. Okay, now let's plug in the numerical values. T minus mu K is 0.5. Okay, and FNB here is 19.6. And then MB here, what is the mass of P? 2 kilograms, so I have 2A. And we can isolate this, right? So I have T minus 2A, that will equal to 0.5 multiplied by 19.6. And so we'll have our T here, minus 2A. That will equal to 9.8, I think. But let's just plug that for making sure. Yes, that will be 9.8. 9.8. And that will be our second equation. Okay, now we have two equations with two variables. We should be able to solve it. And the fastest way to solve that is by using calculator, right? So let's set our calculator here as equation solver. So this one, number 5. And two variables is number 1. Okay. And then let's plug the coefficients of it. So I will have 1 for T. And then 4 for A. And then 19.6 for the result. Good. And then the second equation, I will have 1 for T. And then minus 2A. And then we'll have 9.8. So here we will have our tension as the X result. So I will have 13.07. So I will have T here is equal to 13.07, and the unit here will be in Newton. And that is the answer for question A. And for question B, we need to find out the acceleration, and that will be our y values. And that will be 1.63. 1.63, and the unit is meter over square second. Okay, now we have the final result. This is the tension and this is the acceleration. Hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.